Okay, so today our objective is dealing with these circles that we've been seeing all unit, but now we're focusing with these circles on the graph instead of just circles in space, right? So we're specifically focusing on circles on a graph. The worksheet that we gave you, we tried to be as accurate as possible with our circles, but they are a little off, so please be aware that they're not perfect, but the practice that you're going to be doing, the circles will be drawn perfectly, so there won't be any guessing, but it is not going to be perfect for this. So we want to find the equation. So just like we have for a line, we know that we have the equation y equals mx plus b, and that gives us a certain graph, and we know that there's certain information that we plug in for the line. We learned for quadratics, for our curves, right, we have a certain equation for that. Y equals ax squared plus bx plus c, and again, there's certain information that we plug for that. Same thing is going to happen for a circle. So just like for a line, we need to know m and b. For quadratics, we need to know our a, our b, and our c. For our circle, our important information, the information that we need to know in order to write our equation, are going to be these two things. The first one is, where is the circle starting? Right? Where are we drawing our circle around? So the center of our circle is a key point. And then we want to know how big our circle is. So great, if the center is at 0, 0, is it going to be a tiny circle? Is it going to be a large circle? What do we need to know that determines that? The final part is the radius. So these are going to be key factors in our equation, in the same way that m and b, slope and y-intercept, are key factors in the equation of a line. So if the if the circle is centered at the origin, how could we find the radius? All right, well, here I have an example, centered at the origin. So here's my center. My radius can be drawn any direction, right? I have a ton of different radii here, but I'm just going to pick a specific one. How would I find the measure of this radius? Right? Can I just count and find that radius? Not necessarily. So there has to be a way for me to find this measure. Well, really all I'm saying is, what is the distance of this line? How did we learn way back when to find the distance of a line on the coordinate plane? Well, I want to know how much is that line changing in the x direction, how much is the line changing in the y direction. And so if I can count my spaces in the x and count my spaces in the y, I can then use an equation to find that distance, to find my radius. All I'm really doing here is Pythagorean theorem, which is just the distance formula. And remember, our distance formula, we have our change in x squared plus our change in y squared is equal to my hypotenuse squared, or in this case, it's my radius squared, or sometimes we'll say distance squared. Right? And change in x, I'm just subtracting. If I'm going from here to here, how much is it changing? If I'm going change in y, I'm subtracting from here to here, how much is it changing? Right? So it's just Pythagorean theorem, it's just distance formula. So really, all I'm doing is I'm taking this formula, my Pythagorean theorem, my distance formula, that is the equation of my circle. Right? By using that change in x, I'm just saying my x squared plus my y squared is going to give me my radius squared. So if my equation is centered at the origin, this is the formula. This is the formula for my circle. X squared plus y squared equal to radius squared. Just like m was important in A, B, and C, here my radius is what's important. We leave the x, we leave the y. So looking at this example right here, I do see that my circle is centered at the origin. Again, we're trying to get this to be perfect at 4, but it's a little off, but it's very close. So I want to write the equation of the circle shown. So I know that my x squared and my y squared will always remain when my circle is at the origin. And now I just need to find my radius, right? So do I need to do some sort of crazy calculations using the Pythagorean theorem for this circle? No, because this is a nice circle where my radius is just a counting distance. I can see that this radius right here just goes straight from 1 to 4. Same with this radius, this radius, this radius, right? I can count and see that I go 1, 2, 3, 4 spaces. So my radius is just substituted in 4 squared, and I simplify. So my final equation is x squared plus y squared equals 16. And that's all there is to it. But as we know, not all circles are centered at the origin. So when our circle is centered at the origin, we have this really basic formula. When we have a circle that's shifted a little bit, like the next example, right, our equation changes a little bit. Right? It's still important for us to have those two factors, right, our two key points. We still need to know where the center is. We still need to know what the measure of the radius is. I'm still using distance formula. And my concept of the Pythagorean theorem. But it gets a little more complex. And here we see up at the top, it says the circle is centered at HK. Right? HK is just the generic letters that we give for an X and a Y when something has been shifted. Right? So I'm going to call my center HK. So here is my center of the circle. HK is what in this example? My center in the previous were 0, 0. Now I can see that it's clearly not 0, 0. So my H is going to be 6. And my K is going to be 3. So before I was saying, okay, well, I just did Pythagorean theorem. I kind of drew my circle using 0. And I said, okay, I went over this many spaces, I went over this many spaces. Well, now if I go back to my Pythagorean theorem, I don't want to start from 0. If I create a Pythagorean theorem on my circle, my Pythagorean theorem is going to shift a little bit. That's not what I wanted to do. Here we go. So here is the change in x. Here is the change in y. I don't want to subtract from 0. I need to take into account that my circle has moved over from 0. So I'm going to say the x minus my x value, where the new center is. That whole thing squared. I'm still really dealing with Pythagorean theorem. When it was centered at the 0, this was x minus 0. I didn't have to write this h because it was 0. But now, because of the shift, I need to take that into account when I'm doing my Pythagorean theorem. Then I had my y squared, but now it's not y minus 0 anymore. I've moved my y a little bit. And we're calling that yk. So y minus k squared equals my radius squared. So it does change the formula a little bit, right? And now here, when I was saying the important things that you needed for your y equals mx plus b were the m and the b. And the things that we needed in x squared plus y squared equals r squared were the radius, right? Because the center wasn't that important in this example, but when the graph shifts, we do need to have our x minus h. That h needs to get plugged in. And then my y minus k squared, that k needs to get plugged in, equal to my radius squared. My radius needs to get plugged in. So those key points, the radius and the center in our equation, are just like the slope and the y-intercept. Those are the things that need to get plugged in. We're going to keep our x and our y just like in slope intercept. We're going to keep the x and the y if it's at 0. And we're going to keep the x and the y if it's shifted. The things that we need to fill in are the h and the k, which are the point at the center, and the radius, which we can count. So, let's go ahead and look at this final example. The center for this one is a little bit tricky, so I'm going to give you the center, which is negative 6.5, so negative 6.5, and 2.5. Right, so the center is kind of in the middle. So I'm going to count back 1, 2, 3, 4, 5, 6, and then go halfway, and then I want to go up to 1, 2.5. So really, it's kind of right in the middle here. So again, if I'm saying that my center is negative 6.5 and 2.5, what I'm really saying is my h is negative 6.5, my k is 2.5. So I know those are important things that I have to plug in to my equation. So I found my h and my k. I also need to know the radius, which I can find just by counting. So my radius is how many spaces? Well, I can count 1, 2, 3, 4, 5 and a half, because it is kind of in the middle. So my radius is 5.5. So I just plug these things in to my standard equation. My x stays. I have minus, and then I substitute in for h, which is negative 6.5. That whole group gets squared, plus y, I substitute in for my k, which is 2.5, and that whole thing is squared, equal to my radius, which I calculated to be 5.5 squared. So then I want to simplify my groups as much as I can for my final equation. So what happens when I minus a negative? I am going to have x plus 6.5 squared plus y minus 2.5 squared equals my 5.5 squared, which gives me 30.25. This is my final equation. There's nothing else I need to do here. A lot of times we see this and we're like, oh no, we have to do Bach's method and I have to simplify and I'm solving. No. Right? It does look a little confusing, but like I said, so does y equals mx plus b until you get used to it. Right? So looking at an equation, you should be able to identify key points, and looking at a graph, you should be able to plug those key points into an equation. So let's do a few examples. Go ahead and turn your packet to the next page, and if we look at example 1, example 1 may tell us x squared plus y squared equals 4. Right? They want us to find the center and the radius. So the center, right, is this an equation that I use when my circle is centered at the origin or when there's a shift? Right? So if I look back at my examples, I know that when I don't have any h and k involved, my center is at the origin. So right away I can fill out my center. And I know that this final part is my radius, but it's part of the equation x squared plus y squared equals radius squared. So 4 is actually equal to the radius squared. So how do I get just the radius? I need to take the square root of both. So my radius is 2. And then let's also look at the example number 3. Here they're giving me x plus 1 squared plus y minus 4 squared equals 16. Again, they want me to find the center and the radius. So looking at this equation, we can see it's very different from equation 1 because here we do have the h and the k. So I know my center is not going to be at 0, 0. Now we have to remember that our formula was x minus h squared and y minus k squared equals to our radius squared. So if I'm looking at my center and I'm seeing that it's positive 1, I actually have to remember that this was x minus a negative 1, and that negative 1 turned to a positive. So I'm going to actually take the opposite of the sign that I see. So this is going to be a negative 1. And I also have to remember that this was minus k, so this was like y minus positive 4. So I have to remember that the k that I plugged in was actually a positive. So when I'm looking at my equation, my center is actually going to be the opposite of what I'm seeing. And then same thing, this is representing my r squared. And so if 16 is equal to the r squared, I want to find just the radius, which means my radius is going to be 4. So come ready to practice these equations tomorrow and be ready for questions. See you then.